this is section 3.1, part B. We're now going to talk about simplifying rational expressions. When you think of rational expressions as just fractions with algebra, simplifying equates to the idea of reducing to lowest terms. I want to quickly remind you what we're really doing when we reduce a numerical fraction to lowest terms. We do it so automatically we sometimes don't think about it anymore. But here's what's really happening. If I looked at the fraction 12/15 and I wanted to reduce that, most of you would see very quickly that 3 goes into both of those. So I'm going to deliberately write them as 3 times something. 12 is 3 times 4. 15 is 3 times 5. If I now separate into a multiplication problem, the 3/3 times the 4/5, write it that way. 3/3 is really just 1. And then 1 times 4/5, of course, would still be 4/5. That's what's really behind the whole process that you do when you very quickly, mentally reduce a fraction to lowest terms. What I want to emphasize now, though, is what is really the key to this process. This only worked because we were working with factors or multipliers. It was essential that I had that 1 times 4/5 so that I could just get the 4/5 at the end, a multiplier of 1, of course, not changing the value. This does not work when things are added, when things are subtracted. You must be able to look at multipliers or factors in order to use this process of reducing. That's going to remain true when we look at algebraic fractions. We will have to use the factored form of both the numerator and the denominator. Once we have the factored form, we'll look for things like this that we can reduce to factors of 1, just like we did with the numerical fractions. Let's give this a try. So in example 1, I definitely have addition down here in the denominator, and I know I can't start reducing while I have addition or subtraction. I must have multiplication, must have factors. So let's begin by factoring the denominator. It looks like we could take out a GCF of x squared, leaving us 7x plus 4. And now notice on the top, we have 4 times x squared. Those are multipliers. On the bottom, we have x squared times the quantity 7x plus 4. So again, multiplication there. I can now look at this x squared divided by x squared and say that's really just a factor of times 1. Since multiplying by 1 doesn't change the value, I can go ahead and reduce this to 4 over 7x plus 4. And there's my lowest terms answer. All right, let's try this a couple more times. In number 2, I have both a numerator and a denominator that have adding and subtracting, so I'm going to have to factor both. And I'll start on the top. That's just a difference of squares, 3x and 2. So I'd have 3x times 3x. And then to get the negative 4, I'd have positive 2 times negative 2. And there's the factored form on top. The denominator is going to take just a bit more work. The trinomial with the leading coefficient not being 1. So let me just kind of work that down here a little bit so I got a little space. If I take my denominator, I'm thinking that I wanted a sum of 11 and a product of negative 60. I think we're going to go with 15 and negative 4 on that Definitely adds up to 11, but when I multiply, I get negative 60. So, rewriting this, we had the 6x squared. I'm going to replace the plus 11x with plus 15x minus 4x. And then I still have that minus 10. Factoring by grouping, I can take out a 3x here. Makes that 2x plus 5. And I want to factor out a negative 2 over here. That also gives me 2x plus 5. And so I've got 2x plus 5 as the common binomial. I'll factor that out, leaving 3x minus 2. Okay. So that's going to go into the denominator. All right, so I've gone from a problem with adding and subtracting to a problem that's really multiplication. It's this times that. This times that. That's what makes factored forms so helpful here. I'll now notice that 3x minus 2 is in both the numerator and denominator. So I can say 3x minus 2 divided by 3x minus 2 is actually 1. But since multiplying by 1 doesn't change anything, I'll end up with 3x plus 2 over 2x plus 5. All right, we'll continue to try this for another example or two, kind of using this as an opportunity to review some of our factoring along with our reducing to lowest terms, so that's a good thing. In number 3, lots of adding and subtracting, so I know I can't start doing any reducing until I've got factored form. And as I look at that numerator, thinking sum negative 3, product negative 4, let's see, that would be negative 4 and positive 1. So I think I could factor the numerator right away. X squared would be x times x. And then my numbers, minus 4 and plus 1. The denominator, because it has 4 terms, is going to take just a little bit more work. 4 terms, I know I'm going to use the grouping method. But again, let me just sort of do that down here out of the way. I'll factor out an x squared, and that makes x minus 4 in the first group. Plus I'll factor out a 3 here, also giving me x minus 4 rather. So x minus 4, my common binomial, times x squared plus 3. And so I'll put that up here in my denominator. All right, once again, now that everything's in factored form, I'm seeing multiplication on the top, multiplication on the bottom. Those are factors or multipliers, meaning I'm now ready to reduce. X minus 4 divided by x minus 4 is 1. So I have 1 times the rest of this. And again, multiplying by 1 doesn't change the value, so I can write the final answer as x plus 1 over x squared plus 3. All right, number 4, we'll begin the same way. On this one, I have both a numerator and a denominator with adding and subtracting, so I know I need to factor. And let's see, that numerator is a sum of cubes. That's one that we don't necessarily have the formula memorized for, so let me start by just reminding you of the formula for the sum of cubes. It looks like this. And in this particular case, the A would be the x, and the B, that's actually B cubed. So B would have to be 2, since 2 cubed is 8. And then I'm just going to go ahead and plug in. A plus B becomes x plus 2. A squared would be x squared, minus AB, minus 2x, plus B squared would be 4. So there's our numerator in factored form. The denominator, I first of all see a GCF here, a 5x that I could take out, and then it may factor after that. So once again, I'm going to kind of move to some workspace near the bottom and work with that one. Let's start by factoring out a 5x. I'll have x squared minus 2x plus 4. Inside the parentheses, I'd be looking for a sum of negative 2, product of 4. But since 4 is 1 times 4 and 2 times 2, I'm not going to get that anywhere, so I can't factor anymore. And actually, I guess I could have put it right in up here, but let's bring it back up. This is the fully factored form. Doesn't factor any further. All right, multiplication on the top, multiplication on the bottom. These are true factors, making it okay to reduce. And in this case, this whole trinomial is the same top and bottom. So I divide them out. Dividing anything by itself just gives me times 1. And therefore my lowest terms, or reduced answer, would be x plus 2 over 5x. All right, so that is reducing algebraic fractions to lowest terms. There's one special case that we'll come back and do in the final video for this section.